Great. Good morning. Thanks for having me to talk about the tropics today and on the subseasonal discussion. I've brought some colleagues with me from Commodity Weather Group, Joe Woznicki and Dr. Adam Stepanek, and they've been helping on tropical issues with our team as well. So I thought that'd be good. And you guys feel free to jump in on any of the slides that I show here as well as we walk through it. But Michael had sent me a bunch of questions, and I think a lot of these slides will address those questions, but there may be some more at the end that we can address as well. It's maybe it's a good time to talk about the tropics. We're taking a bit of a break. Elsa is leaving the scene out of the Northeast there. She's quite noisy. New Jersey, New York this morning, but it seems like there's nothing else in the pipeline at this time. Uh, Adam had done an article for our customers about 2 weeks ago or so, something like that, and talked about some of the key ingredients that we look at for tropical cyclone development. And some of the challenges are getting that pre-existing disturbance, of course, and certainly certain qualifications. Is it 80? It's 80 degrees Fahrenheit, right, Adam? That's the key number there.
Yep, got to get into the right window. Yeah, looking for about 80 Fahrenheit, 26,
Yep.
27 degrees Celsius. Warmer is typically better, so we'll take what we can get.
Yep, and you can see these are like all the tracks of all the different storms. You can see that's a pretty amazing graphic there, I thought too. I wanted to talk about it in terms of like industry and impacts. My first hurricane that I did after I left college was Hurricane Opal in 1995, and you can imagine there weren't that many weather models back then. It was a very stressful time trying to figure out what was going to happen with the storm because we look at back in the day. I mean, it was really the production area was the main concern with hurricanes, and it was heading right up into the eastern production area toward the Mobile Bay area, and it just lollygagged down there in the Bay of Campeche for a number of iterations, and just no one knew when it was going to, get pulled northward and make its turn to the northern Gulf Coast. So it was a very stressful time period dealing with it. And of course, it intensified pretty dramatically there in the Middle Gulf as well, and became a very intense storm. And the traders were all over that. And back in those days, in the mid 1990s, you didn't have very much ensembling. You didn't have any really ensembling, and you just had a very limited amount of weather models. I think there maybe were four that we had to work with at that point. All dynamic models, not really any ensemble guidance, but things have come a long way since, and the industry has changed too, because in the beginning, when we first started consulting for energy back in the 90s, when natural gas got deregulated, the main issue was the production platforms, offshore production platforms. As you see here, all these little speckles here are areas where there's rigs essentially, and anything from a Cat 3 or stronger could damage those rigs and cause trouble. So a Category 3 was always the threshold of concern for these facilities. But now things have changed quite a bit. Now we have to talk about LNG facilities, Shear in southwestern Louisiana, for example. And these facilities can really impact the markets if they get impacted and not able to operate if you have a major hurricane impact. And then the other thing that's really changed a lot is, instead of trading just natural gas, we trade, clients trade electricity, and so demand destruction becomes a big issue as well. If you have a storm hitting a major metropolitan area, then all of a sudden you have really significant impacts on power prices as well. Demand destruction in terms of just killing heat in the summertime, but also in terms of power outages, where you see significant reductions in power usage during that time. So it's changed quite a bit. It used to be hurricanes, I would say, were bullish for the markets, and now and this is still true for LNG as well, but for the demand destruction component, it's actually more bearish. And I feel like it's because of the shale revolution, because of a lot of onshore production of natural gas in West Texas and the Dakotas and Pennsylvania. The impact on the rigs is not as big as it used to be in terms of the overall impact on natural gas production. There's smaller percentage there in the Gulf than what it used to be of the entire national production picture. So there was some questions about, what models do better and everything, especially like medium to long range, where, that's when the markets really key in on tropical events, because it's kind of outside the range of the Hurricane Center and Short Range National Weather Service forecast. And, the old rule of thumb was that the American models tended to see the storms fastest, they would pick up on a storm development before the European, but they would have a high false alarm rate as well. So it's, kind of pick your poison there. They'll see the storm before anybody else, but they'll see three other storms as well. So you have to kind of pick through the noise and say, okay, this one might be a little bit more valid. The European tended to suppress development deeper into the future more often than the American, so it tended to have the other problem where it would miss storm development initially. But in the old days, the European used to be better at tracking them. They used to be the more skillful one, but it seems like the GFS model upgrades in the last 2 or 3 years have made some strong gains against the European, and we just saw that this past week with Elsa. This is something I posted from our Storm Vista website back on July 1st, last Thursday, and when Elsa was way out here in the central Atlantic, and the European was curving that system well off to the east. Canadian was on the east coast of Florida, and only the American was on the west side of Florida. It wasn't exactly accurate, but it was definitely a lot closer. The Hurricane Center took a middle ground approach and did very well with that storm track coming into the Florida Keys there. So it's really interesting. Of course, you could say, well, the NHC is better. In the old days, they would only go out 3 days. Now they go out five, and so they're getting more into the medium range picture as well with their forecast. And again, it seemed like the European and Canadian had to make more of a movement to the left side of Florida to catch up to the reality, while the American had to come east a little bit, but it might have been a better forecast. You could see I put this out on, I forgot to date this one, but this was, I think, the next day on July 2nd, last Friday, and you could see it had moved along a little closer to the Lesser Antilles, and things tightened up a little bit. But again, the American kind of gave a better signal that, well, it's going to scrape the Eastern Gulf, and indeed it did. So that was interesting. A lot of times the European was also weakening the system, tearing it apart with wind shear and interaction with Hispaniola and Cuba, and not really allowing it to survive. I think there were a few moments where I thought it may have been sheared apart pretty well as well, but the Hurricane Center kept it intact all the way through. In terms of a lot of these questions and factors, that they really do vary based on the situation at hand. The development lead time. I always think of it as terms of these three C's basically. If you have a strong consensus, if you have multiple models showing a development area, then it's 12 days in the future. It's got a good chance of verifying. If there's consistency from cycle to cycle, it's got a good chance of verifying. And then credibility. Is it developing an area that makes sense? Is it underneath of a ridge, or is there a certain upper level pattern structure that looks supportive for tropical development in that area? So those are the three things to really look at in terms of, will it work at that lead time? I've seen lead times, really short lead times, fail spectacularly because some of these things aren't being met. Maybe it's just a noisy back and forth on the GFS operational model rather than a consensus across all the models. And in terms of track errors, the National Hurricane Center's cones are based on the standard error range. They've been slowly tightening that range over the years, and they make a big announcement when they do that. But and so they're getting better and better with that over time. And of course, as usual, it's the closer you get to verification, the better skill you're going to be. The models will come together, and it does vary again based on the synoptic background state and the influences there. And then intensity challenges. Again, that varies on location and timing as well. If you have a storm like Opal that went across the loop current, you saw that major intensification, and more recently Katrina, when it went across the loop current that fateful Saturday, the storm really blew up when it went over that much higher heat content water. That can really affect rapid intensification, and I think rapid intensification is more likely when you have a well-developed storm that's already on its way, category 2 or 3. That's usually when you see that more often, but it's also hitting key areas like that, or a significant relaxation of shear can do that as well. I don't know if Adam or Joe have any inputs or thoughts on like the state of the science and anything I missed on these issues here.
Well, I just wanted to point out, I think not necessarily just the loop, obviously like you say, like the loop current here, but like Harvey had some really, really warm waters that, that allowed it to rapidly intensify so quickly like it did in cases like that as well.
Yeah,
So, it doesn't just have to be in that
no.
Katrina zone either.
No, it doesn't. That's for sure. Yep. And this is just like one example here,
Yep.
like what it looks like today. But there's, if you've got some other areas that are really, really warm pockets and stuff, it can really make a difference.
That's one of those things too, where we look a lot at the sea surface temperatures, but looking at the depth of the heat in the water, there's other measurements like tropical cyclone heat potential that'll measure the upper layers of the ocean. The idea that these hurricanes are going to churn them up a little bit, and so is there some other warm water there just waiting to replenish the warm water at the surface? And so the more we learn about that, the better things are going to become as well, especially for those sharp upticks in intensity.
Yes, that's important. That's kind of what I'm trying to show here with that altimeter stuff. I had a link for SSH, sea surface height. So the sea surface height measurement is a way to see how deep the warm water is down below it, I guess, or something like that. But that was a very helpful tool. There was a really great site that did that really well, but I can't find that anymore. So, yeah, I think you're right. That's a real key thing is the depth of the warm waters is very important too.
I just wanted to jump in. You noted
Yeah.
with ELSA that ECMWF was too far east in the track. And I think there's a known bias where the ECMWF in particular seems to be too slow, I think, propagating tropical systems, at least. And then that turns into, for a curving system, a bias to the east.
That makes sense.
Consistent with something. I mean, have you noticed this with other storms too, that European could not tend to be too far east for these recurving systems?
There was the other issue that makes a lot of sense to what happened with this one, because there's this other issue where, if a storm gets stronger faster, it tends to, pick up on the mid-latitude jet stream and turn to the north faster as well. So you get recurvature quicker with stronger systems. And in this situation, the European was much weaker with the system than the American. So it didn't make a lot of sense that it was curving north so quickly. And I say quickly in terms of compared to the American, but that would make sense that because I don't have timestamps hatched on each one of these, but it would make sense that the European may have waited longer for the trough and was slower with the storm itself, and that's why it curved to the north ahead of the trough that's coming in right now, actually. So yeah, that's interesting. That makes a lot of sense. I had heard a different theory that the reason the European was struggling with this was it was having trouble with the land interaction with the Dominican Republic and Haiti, and that was causing its turn to the north a little bit more aggressively than the American. But I think your slow bias makes a lot of sense. That does sound right to me. And Joe Woznicki made this forecast for our team back in March of 2021, and I think I got the score right so far. Down below, we're at 5 named storms, I think, with Elsa here.
Yeah, so I mean, our numbers are pretty high there, but I was mentioning to Matt earlier this morning that I've been doing this for 5 or 6 years now, I think, since I started at CWG, and I hit the number of named storms once, and then the other 4 or 5 times I underestimated how many named storms there would be. So I think that's partially because I wasn't factoring in enough the technological changes and factoring in some of those earlier years that they didn't have as good of ability to detect them. But I think it's also the Hurricane Center is much more lax in their naming, it seems, over the recent years as well. So I tried to factor both of those things in and go on a pretty high number.
Yeah, I'm feeling my age on this stuff because I keep saying back in my day, back in the 90s, they never used to name subtropical storms. They would not give them a name, and now they do. And there's a lot of things that they name now that they didn't used to name back in the day. So yeah, so I think it's better to air high, I think. And I think Adam posted this yesterday, and it's Phil Klutzbaugh's team at Colorado State just updated it yesterday, and they're up to 20 named storms to match your forecast now, Joe, as well. So I think everyone's in agreement. I think it's partially just catching up because that Danny storm last week, I mean, that was like what a half a day storm or something like that into the southeast. So there was a name right there. So yeah, it's everyone's kind of increasing their numbers, it looks like, at this point.
And I think the La Nina situation, it's officially public now, La Nina watch as of yesterday. So I think that's
I saw that
grabbing some attention as well, with the potential to decrease the shear there into the core hurricane season.
The core part of the season, yeah, that's probably a big issue for as we go towards September and October. I was intrigued by this, the SST anomalies. This looks worse than it is because of the revised climatology. Now it's 91 to 2020 climatology, but it does look, not as warm out across the Atlantic Basin in terms of heat content for how strong the storms can get. So that is an interesting thing. We're calling for 5 major hurricanes this season, and it looks like Phil Klutzbaugh's going 4 still at this point on his list. So that may affect the top end. Maybe we'll have to watch that, I guess.
Yeah, but I mean, even as Adam mentioned earlier, I mean, the 80-degree threshold. I mean, it's still the
Yep.
waters are
Oh no, I
still
know
fairly warm. So I
they
mean,
are. They'll meet the
yeah,
requirements to get there. Yeah.
yeah. But yeah, I agree on the top end
Hmm.
thing that could limit that to an extent.
Yeah, so you could see the this year versus last year here across the main development region here as well. A little bit of a pullback in terms of the heat content that's out there. So it'll be interesting to watch. You can see, I guess this is only up to the 6th, so I was surprised that, which is Tuesday. I'm surprised that you can almost, else is probably just, I guess that's about the right timing. Yeah, Tuesday, Wednesday when it was going up through western side of Florida there. But it was already kind of churned up in the eastern Gulf. And wind shear from this morning, Joe mentioned wind shear, and looks pretty vigorous out there right now. You've got an upper level trough. We call that a TUT signature there, and that's a tropical upper level trough, and that's going to prevent significant development right now in this area. Any of these red areas are high wind shear that tends to rip apart high altitude thunderstorm development and creates an inhibiting factor. So as of right now, the Hurricane Center has nothing on their radar over the next 5 days. They have everything fairly quiet. I was looking back at last year, and we actually had a break last year between July 11th and 22nd. We didn't have any named storms as well. So it seems like we're in this little bit of a mid-July lull here as well. I think there's some climatological support for that too. And the models are really quiet. I show the European here, but even the American ensemble with 0 and 6Z runs don't have any activity across the Atlantic Basin over the 15-day window. I did notice the 6Z operational run had a vigorous tropical wave coming off the African coast by the weekend of the 24th or 25th of July. So maybe way out there. We'll have to watch the Cape Verde season pickup as it tends to do as we head toward August. It's active on the Pacific side, though. We've got more activity forecast to develop off the west side of Mexico and maybe some West Pacific typhoon activity as well. Michael, you had sent one question along about recurving typhoons, and that's a challenge. In 2017, in late July, we had a recurving super typhoon Noru, and I believe that helped to contribute to a very, very cool August pattern over the lower 48 as it recurved and helped to pull that ridge structure westward across the North Pacific. We had a professor, I think from NC State, speak last summer about this issue, and the science is still evolving about it. They're doing work to suggest the idea that the pattern, the high latitude pattern, actually changes prior to the recurve, and it's a chicken egg argument. The recurve is symptomatic of the change that occurred rather than the recurve causing the change. So it's really interesting. They've done some interesting research on that, and it's this still kind of an evolving thing. But in my experience, baseline criteria for something to trigger a pattern shift is you have to usually have a super typhoon. There was that tropical storm, I can't remember its name, 2 weeks ago. Had an extra vowel in the name that recurved, and it was just ahead of the Pacific Northwest record heat event. And I know Dr. Roundy had said that he thought that helped amplify the wave train to help the record Northwest heat from last week. And so it may have played a role in that. It didn't really change our pattern over the lower 48, it just amped it up a little bit. But for a significant pattern change, I usually have to see a super typhoon to make like Noru to make that happen. There were a few other ones, I think in July of 2014, maybe there was a really big one, or maybe that was November 2014. But there was a really big one in 2014 that also caused a big problem. Usually it's what I've seen in the past is mid to late summer, and then also in the late autumn. I've seen a few cases that have done this as well, but not so much other times of the year. Have you seen much work, Adam, on recurving cyclones or anything in terms of changing synoptic patterns?
There is, as you say, stuff out there, but it's not one of these levels of our science that has a really strong consensus at this point. The idea that, as you alluded to, the chicken and the egg, I think there's maybe a little bit more of a push towards the idea of the cyclone itself, the tropical cyclone, influencing the larger scale pattern. But there's a lot that's still being worked on, to my understanding, within the topic.
Yeah, that's for sure. Yep. So as a result, in the energy markets, it's a big talk of speculation. Whenever you have a big event like that, it gets everyone worked up. So for sure. So
Hey,
yeah,
oh,
sorry.
sorry. This is Dave. I just had a quick comment question. That's okay.
Yep.
I was just thinking back to what you were saying about how there's a little bit of lull in activity, and how it almost like talking about it a little bit surprising, like surprising to see that, and I understand that, but it's funny, and this is maybe my age too, but you look at the calendar, right, and it's still the first half of July, and
Yeah.
I remember a time when June, July, you just didn't think about much, and
No.
climatologically, there just wasn't a lot of activity. If there was, it usually wasn't really a strong storm. I feel like around 2005 or so kind of seemed like an inflection point where some of that changed.
Mm-hmm.
But it's funny now how we talk about it. And again, it's only early July, but we're acting surprised. Can you, and and then I guess my question there, can you talk a little bit, you or Adam or Joe, about the climatology, of storms, and how you don't have to be exact in terms of the quantification, but and maybe how that's also evolving, because I don't have hard numbers in front of me, but it does feel like the frequency of July storms has increased, say, in the past 10, 20 years as compared to before that. And part of it probably is exactly what you said, that the fact that the Hurricane Center, for different reasons, is naming storms more, maybe some of the guidelines and such, and maybe for cautionary reasons, but it does also seem like there's just more activity that's out there now. Any thoughts on that?
Yeah, it's interesting. I don't know. Uh, we had the old AMO cycle, right? And we were at the back end of. I guess we started. We had that really big season in '95, but we had a real quiet AMO period, and now we're back mostly in a positive AMO cycle, I guess. So I mean that might be contributing. Also, maybe the negative PDO, where we're getting more frequency of La Nina events. We've had several La Ninas since 2005, multi-year events as well, that may be also contributing to this too. But then the general, long-term climate increases in oceanic heat content also playing a role. So there may be all three of those factors may be involved. I guess it was Dr. Mann at Penn State was saying that the AMO doesn't exist, so we shouldn't look at that cycle really. So there's some debate about whether that is a real index or not. But there were historic periods when, like in the 60s, 1950s and 60s, when we had very, very aggressive hurricane seasons as well, with a more positive AMO period. And we've been mostly positive on the AMO the last several years now, and then from a PDO perspective on the Pacific side, the negative PDO tends to favor more frequency of La Ninas and La Nina-like patterns. So we've been getting La Nina-like summers tend to be hot in the U.S. and they tend to be stormy in the tropics. So I think all three of those factors may be playing a role. I don't know if Joe or Adam have other thoughts, but that's my guess at this point.
I can jump in for the couple quick things. I think that that's definitely part of it. I think this is a number one of those, that there's so many different layers that we can look at to try to figure out what exactly is causing the uptick in the last decade and a half. Obviously, the even acknowledgement by folks at the National Hurricane Center of naming storms that would not have been named years ago. But I think some of it is maybe different techniques by NHC and other entities, but also simply improvements in technology. I mean, we have better ability from new satellites over the past 15, 20 years to resolve features that we wouldn't have been able to previously resolve, whether it's spatially or temporally, or just being able to pick up on smaller scale features that may be allowing us to identify a few of these early season systems that would have otherwise simply been, hey, it's a little windy in the Gulf and there's some clouds. And I think that we can do a little bit better in that sense. And you're right, though, in the sense that I've taught classes in the past that deal with tropical, and I've had to basically take my graphics of how June behavior is supposed to be and all but throw them away, because it's not the norm at this point.
Yeah, I think that I think, was it Danny that intensified over land? Did it go from a depression to a tropical storm after it made landfall, or was that the sea storm? I can't remember which one did that, or maybe they
Yeah,
both did.
that was Claudette that went in
Claudette did,
Louisiana
yeah.
that actually got the name. Danny had about 50, 60 miles, I think.
Okay, yeah, that's
I
really
think
close.
landfall was Montgomery, Alabama.
Oh yeah.
It's not even on the coast. So if
We'll call it
you're
city
going by,
fall.
yeah.
Yeah, yeah. Oh man, yeah. So it is interesting. It has changed, and I don't think they would have caught all that as much, 20 or 30 years ago, I guess. But definitely a higher frequency of plane investigations, everything too. So to Adam's point about technology as well. Does that seem fair, Dave, or do you have some other ideas as well? You think?
No, that's great.
Yeah.
Thank you very much.
Yeah, it's interesting stuff. It definitely keeps us more busy as well. I mean, I think other factors to watch, and I think it was mentioned some of the questions, things like the Madden-Julian oscillation. Historically, if you're in phase one, you tend to be supportive of more convection over the Atlantic basin. It tends to be more constructive for storm development. Now we're moving right now more to phases 2, 3, maybe even 4, 5 now, but we're coming out of the Indian Ocean right now with more supportive. You can see that here on the velocity potential. INSO is officially neutral, but as Joe mentioned, they just issued that La Nina watch, so we're going to be moving maybe back to La Nina again as you go into the late summer and early fall, and if you have cooler waters in the eastern tropical Pacific, you tend to have reduced wind shear on the Atlantic side, and so you tend to have maybe a little bit more on the Pacific side and less on the Atlantic with the La Nina setup there, so that may play a role as well. I'm not a huge expert on velocity potential, but this is another way to look at enhance and suppress convection areas, and it's another thing you can look at to see areas that are potentially more active than not. So you can see we're in this area right now of suppressed activity right at this time, and so it looks like it wouldn't be as supportive currently. That's probably helps explain our quiet period that we're going to have here over the next week or two. I think that's pretty much the end of my slideshow, actually. Were there any other questions on the tropical side of things that went the good first 30 minutes of the talk today? Michael, were there other questions I didn't address in there in that list that you had looked at, gotten together?
I just had this is just a couple of
Okay.
things I just wanted to, so how early, or, obviously each situation's a little bit different, but on average, how early do clients want information like the track or intensity or potential impacts?
As early as you can do something, I guess. And then they want it faster than that, probably. So yeah, it's a difficult balance because you don't want to be crying wolf all the time. I mean, there are some people in the Twitter sphere who will advertise every single GFS storm and hype them up. And so you don't want to be that person, but at the same time, you do want to make folks aware of risks. So I guess we try to balance where we try to address where models are developing systems and then talk about what we think may happen with them. But yeah, it's as early as something shows up, and sometimes it's close in. Like there was that year, there was that MCS complex came in to the Gulf from the Midwest and became a storm, and that was kind of a surprise, and it was a close in sort of situation. And then other times it's you're sitting out there in the 11-15 day looking at something where the models are consistently developing it, and you kind of have to talk about it because if you don't, others will, and even if you don't think it's going to happen, you still have to talk about and address it for the customers and talk about its prospects.
We put out reports in recent years on when a storm is actually formed or we're pretty confident it's going to form. We'll put out like confidence risk boxes of it has a 10% chance of affecting Gulf production or of causing demand destruction or something like that. So we kind of we put risk the risk boxes the tail ends will become smaller as we get closer to the event. So that's kind of the it'll be more broad if it's 10 days out, then it'll 3 days out it'll be a lot more fine-tuned.
I see.
One thing we've been having to give out 2 numbers lately too, because it's gotten worse over the years in this respect, but it's better actually. But for the people involved, but they're much more cautious now with systems where they will more regularly evacuate and reduce the production activity ahead of storms, even if the storm's not forecast to hit the area, if it comes within proximity. So I've been doing two sets of numbers. One is the likelihood of damage, actually physical damage that would take a long time to recover from, and then just the idea that they would be shut in, where they would evacuate a rig and just not be operating it, and they would return. So usually the numbers are pretty different. You know, they might have a 10% chance of production damage of getting category 3 or more, but they're probably maybe a 50 or 60% chance that they're going to evacuate the rigs, and at that point they'll be running at a lower capacity and not generating as much production oil and gas.
Okay, thank you. One other quick question. Do you also have like for hurricane intensity, do you have like a similar system where like, you have 20% chance Cat 2, 30% Cat 3, something along those lines?
I, we haven't really done that for all the categories per se. We really just focus on the bottom line for our customers. So
Okay.
will it reach that category 3 threshold for damage or not? That's kind of where we kind of leave it at that. I think in other businesses like in insurance and everything, there may be more. I know that some of the insurance companies and hire meteorologists do exactly what you asked there, and I think they have to do more detailed qualification like that. But for our business, we don't have to get that detailed.
Okay, thank you.
Yeah.
Matt, I had a question comment. Can you talk a little bit about the Hurricane Center forecast cone? Or a little bit more about
Yeah,
that?
I was gonna look that up a little bit more. I don't know if Joe or Adam remembers, but I feel like it was just last year they announced that they tightened their cone because of the skill improvements that they had witnessed, that they had observed, and they were able to tighten the cone in terms of, because that's just their standard error at 4 days, at 3 days, at 5 days. They go back and run the history of all their errors that they made, and I want to say it was just last year they announced that they were tightening their cone, but I couldn't find the article. So
Yeah, I'm not sure when it was either.
Yeah, I'm
but
not sure. Sorry.
yeah, they did at some point, and that's what they do. But so their cone is completely statistical. It's just completely based on what their average error at 72 hours is at 96, and so the cone gets bigger as it goes further into the future. And it's and I think that's really helpful. I think it gives a good idea of where typical. I've seen errors outside the cone for sure, but most of the time I think they're within the cone, and they did a wonderful job on Elsa. The tracking was really spot on there.
Is it, and I can't remember exactly either, but is it something like 70% of the error distribution is expected to be within the cone?
It might be
So
that
like you
number.
said,
Yeah, I can't remember. That
it's,
sounds about right.
yeah, it's
Yeah.
okay. Because like you said, it's not supposed to be 100% or like
Mhm.
I think even like 2 standard deviation if I'm right, but I think it's something like 70%.
Yeah, I have to look into that. I forget what the actual number is on that, but yeah, I think it's a reasonable cone that they offer. It's a lot more improved than what we had 20 or 30 years ago.
And I think their tracks in general have been very, we like to rag on them for naming all these storms all the time,
Yeah.
but I mean their tracking of the storms once the storm forms and their cones and everything have seemed very impressive in recent years of nailing a lot of these big storms.
They use exactly right, Joe. They use like a TVCN, I think it is, which is a compilation. It's a certain ensemble, optimized ensemble that they use to help guide their tracking. I think that's been their secret. And I don't know are they still using the Florida Super Ensemble as well? They had special rights to use that as well. That was supposed to be helpful to them too, but I haven't seen them mention that in their discussions recently.
Yeah, I don't know either. But I remember, yeah, when that whole thing got started, it was big.
Yeah.
Like they had access to it, and a lot of other groups didn't. But
Yeah.
one other question related to the question comment. Um, I agree. So I think the Hurricane Center forecast cone was one of the great developments products of the last whatever 20, 30 years, in terms of applying probabilistic information and in a useful way. But I've often wondered, is there a way? maybe not to improve on it, but at least to add additional value in terms of, if we made and maybe it's not a perfect comparison, but if we made a cone, kind of like a temperature cone for a city forecast, the size of the cone, would it be the same for, say, Chicago versus San Diego, right? Out 10 days, right?
Hmm.
Because the volatility is, variability is a lot less in San Diego than Chicago on a typical day. But with the, Hurricane Center cone, we have sort of a one size fits all, which again, I think is a good starting point. But you guys um, thought about like, looking at a cone that was adjusted or optimize, I'm not sure the right word, but for different conditions, whether it be climatological and model conditions. So climatological, for example, might be, let's look at the errors associated, let's say 5-day errors associated based on the speed of the storm. My guess is that a storm that's moving very fast will have different errors than slow.
Hmm.
Latitude, right? Latitude's a big one, right? Of course, all things being equal, the further north it is, probably the higher errors. The intensity of the storm. And then, so different climatological conditions such as that. And
Hmm.
then, model conditions, obviously different models have different codes and stuff like that. So I don't know, any thoughts on those kinds of research topics and if they could be of use?
Yeah, I think that's a great idea. I think that would be really helpful. It's the usual thing is that the more you slice and dice, the lower your sample sizes go. So, and so your statistical robustness gets, you diminish it depending on the sensitivity of what kind of event you're dealing with. But yeah, I like that idea. That would make a lot of sense to do something along those lines. We don't do that officially, but as Joe mentioned before, we kind of have probabilistic assessments on different directions or the different type of cone that we do, and that's mainly based on our interpretation of majority of the models are to the right of the NHC forecast or to the left. It's not an even cone. There's other factors that we weight to the right or left because you want to try to get a lean basically for the customers. We like the hurricane center track, but if they're wrong, it's probably going to go to the right because majority of miles to the right, or the trough is coming in stronger than expected, or whatever. Those sorts of factors we try to deploy ourselves. But yeah, I think it's a great research topic for a broader application. I think that'd be really cool.
Yeah, and I think the Hurricane Center could even, incorporate something like that into their cones would be, a second step off of theirs if they had an uneven type cone instead of equal distribution on both sides
Hmm.
would definitely be a step in the right direction.
Yeah. We had Phil Klutzbaugh speak to our company last month, and he's really been a proponent of changing a really big thing on hurricanes is changing the classification system for intensity, whether it's not focused on wind speeds, but focused on the surface pressure of the storm itself, and so that you can get better, like Katrina being a Cat 3, and other storms being a Cat 5 that didn't have as much damage and things like that. But if you were to scale them by their MSLP, you would get a much more um, uh, a better alignment with the type of damage that the storms cause and everything like that. So it's kind of interesting. Another angle that they're pushing for that maybe it's problematic because when you're talking to the public, it's easier to explain maximum sustained winds. That sounds scary. If you say what the surface pressure is, it's not really that scary. So they can't visualize it or understand it. But apparently it trues up against damage from storms a lot better than just the wind field being the qualification there, or the primary qualification anyway.
Speaking of that, that's interesting. I wonder too with I can't, I should be able to recollect this, but um, obviously the fact that the flooding from Katrina was, and the levees break.
Yeah, it was
But
extra stuff there
if,
too. Yeah.
well, yeah, no, but like if the levees outside, like have they looked at that? Like if the levees hadn't broken, given way, um, what would how much of the sheer damage and death toll and things like that was due directly to that versus, other impacts from the storm?
Yeah, Phil made that point too in his talk, and he was, he said, look what happened over in Mississippi and everything as well. It was just, he said they did take that into consideration when they were doing their analysis for it was a research paper that just came out like a month or two ago, I think it was, but I'll have to find that for you. But yeah, it is interesting. You're right. There were other factors there that made that even worse than it otherwise was. So, but
Interesting. Okay.
yeah, yeah.
So that's all the questions I had. Michael, did you have any others?
No, I don't think so. I think Matt and Joe and Adam got to all the questions.
Cool.
Great.
Well,
Yeah, if Matt, if you still have a few minutes, we can just take a quick look at the forecast.
yeah, sounds good. I looking at the 16 to 20 day outlook, I didn't want to rock the boat. We've been stuck in the same forecast pattern for quite a while here, so it's been very stagnant and stalled. Very impressive ridge structure over the Rockies up into the northern plains and central Canada. We've got some diffluent heights over the Midwest, so it keeps raining on. Joe and Adam are both in the Midwest, so it keeps raining on them, finding ways to rain on them anyway, and it keeps breaking the heat up, I suppose. So I went a little hotter than the 30-year normal for my forecast. But I pretty much, from a spatial standpoint, I pretty much kept it the same pattern as we've been seeing. So above normal demand over the Northwest, the Rockies. I think I might have just done normal over the Midwest, if I remember correctly. But yeah, it seems like I don't. Yeah, what was the range of people's forecasts? So I was 60.
Looks like we had
I look at the persistence. Yeah. Oh,
yeah,
sheesh.
persistence was pretty strong, of course,
Mhm.
based on June, most of June. But in terms of some of the human forecasts, looks like Josh Herman, 64. And on the cold side, we had, I guess, CFS at 45,
Oh wow. Yeah,
which
CFS has been really cool lately, I've noticed. Yeah.
that has been a story, right?
Hmm.
This summer so far, at least, our sample size is a lot smaller than yours, but it was interesting. We were talking about Dr. Decker, actually, who's on the line. We were talking about how it did relatively well this winter as compared at least to the ECMWF. It was
Hmm.
neck and neck. I think in our study or in our sample size, it actually finished slightly better. But that has not been the case so far this summer. You can see, yeah, the bias is almost 10 CDDs
Mm.
and directionally correct. This is the one that really gets me. So I guess that's a 1 out of 7
Oh
if,
wow.
if my math is right. So one time, this is against the 30-year normal, not even the 10-year normal. The
Wow.
30-year normal, it's been on the correct side once of
Oh,
the 7 forecast. So
yeah.
it's
I
love
have
it.
you it looks like you haven't added the GFS Ensemble weeklies in here yet at all.
No, we
Um,
haven't. We
they've
haven't.
been the other way. They've been running really hot, and
Oh,
so it'd be. I think if you average the two of those together, you might have a really good forecast. So it's been, but in June it did really well, being so hot. Now here in July, we just finished the. We look at it from an EIA week standpoint. We just finished the 7-9 EIA week here today, and as of yesterday, and it actually ran cooler than a 30-year normal. So it'll be interesting to see the CFS may get some make up some ground here or not.
right. And I think yeah. This is the last. I was going to say, if I remember correctly, you did quite well in this forecast
Mm.
here. This is our last verification, Matt.
Okay.
Um, so it's a few more days old now since we're doing the thing on Friday, but this is from June 30th to July 4th. And let's see, the verification came in at just under 50 CDDs.
Hmm.
The 10-year is 56,
Yeah.
and the 30-year was 52. So yeah, we
Got a
actually
cool period. Yeah.
yeah, the cool side. And your forecast was very good up top here. And then we had some not so good forecasts. No, I won't say who.
The
Me.
numbers are small this time of year, though. They're not
Yeah.
that bad. Yeah.
But yeah, I mean, and it's impressive. So June 30th, July 4th. I mean, here I'll just pull up on the as they say in the business, the other network.
Yes.
Watching Johnny Carson too much. He used to say. But here, let me pull up the Just do the anomalies here so we can see the map. Oh, what did I do wrong?
You're going through July 30th. It looks like there. You're
Oh,
trying
yeah,
to
that
do.
would do it.
Yeah. That's the pattern of the ridge in the northern Rockies up into the Canadian prairies and western Canada there.
Let's try this again. There we go.
Yeah, that's an amplified version of that.
Yeah.
Yep.
And
Yep.
oh, and then speaking of the CFS real quick. So we were just talking about CFS, right? So the CFS actually, this, again, wrong side of the 30-year normal. So it was actually a little bit warmer than the 30-year. But if I remember correctly, the pattern was even worse. So it actually went pretty, for the CFS, this looks like a pretty strong warm pattern in the east. And of course, we know what happened. So
it didn't do good either.
Yeah, it's not just bad
Still
luck.
lost. Yeah.
Right. It's not like,
just a
well,
bias.
it
Yeah.
got the spatial pattern right, but the 2-meter temperatures, whatever, it just doesn't interpolate well.
Yeah.
No, that was a disaster all the way around. So. Yeah, so maybe we'll have to switch to the GFS ensemble extension here soon because
NOAA's going to do that. Yeah, they're planning to retire the CFS at some point and make the GFS ensemble weeklies their primary guidance for that period, for the subseasonal period.
And here we'll look at one other thing. Let's look hemispherically, globally anyway. And I cheated on this earlier. Again, just not good. Here, maybe I can put it side by side ish.
Yeah.
Get the 500. Yeah, there we go. Pretty close match. I mean, in terms of the dates.
Yeah, the dates are good.
Yeah, Canada just.
Yeah.
I feel like we've seen this before, like with Canada, and I mean Greenland. Just Canada over to Greenland is just a complete miss. What can you say?
Mm-hmm. It got the Aleutian low okay,
Yeah.
and the ridge in the Northeast Pacific, so it had that feature. It did
Yeah.
well out there. It just displaced the location of the vortex northwest of the Hudson Bay. It actually was up toward the Davis Strait, more upper Greenland looks like.
Yeah.
So, yeah.
Yeah, exactly. I mean, a lot of times you look at the Pacific as an anchor, and
Yeah.
if it does fairly well over the Pacific, then maybe it'll do okay, Rossby waves. But yeah, I mean, you at least looking at this, eyeballing it does not look too bad from, like you said, to Aleutians into the Eastern Pacific in general. But once you get into central Canada and eastward, so I don't know why. Like I haven't looked at it long enough to understand in terms of the attribution. Like what did it miss? Why were there such errors across Canada or in Greenland, which then impacted and over to Europe too, right? I mean, it's Canada. Yeah, I mean, it's completely basically opposite of trough ridge trough, as per the CFS versus ridge trough ridge kind of evolution there. But be interesting to look at. Yeah, I don't know. Any thought? Did you guys have a chance to look at that at all?
Not really. I was curious to see if I can look at I was trying to figure out what the forecast date was. That was June 15th, Tuesday, and I was going to see what the CFS weekly forecast was.
How much does this project on the AO or NAO? Is this sort of the inherent unpredictability of those oscillations at this time scale?
That would make sense, yeah.
I don't know if we can pull up what the NAO forecast,
Yeah.
Here are the forecasts of what actually happened in terms of the AO or NAO.
It was forecasting an MJO of phase 1, and instead it was 2 and 3 in the Indian Ocean, so it was off on its MJO forecast. MJO is so weak this time of year, yeah. But that was one issue. But I think the AO is a good point, Dr. Decker mentioned, because the AO has been really, really positive lately, and that northward shift in that vortex, you could see that was a miss on the CFS.
The AO has been one of our most, the highest teleconnections we've been looking at least intensity wise,
Yeah.
So yeah, I mean, it definitely I guess to Dr. Decker's point here, what did we say? It's June 30th, July 4th. So especially at the tail end of this, it ended up verifying more positive for sure than was anticipated. This is obviously 14 days out, so assuming that it represents the 16 to 20. But and just looking at it visually, right? Yeah, it definitely does seem like you can see that how that verification was much more positive. Still, though, doesn't quite answer the question in terms of why did it handle this AO pattern so poorly?
I think it had trouble with the tropical forcing too, from what I can
Tropical
tell
forcing.
here. Yeah, it was phase one, and it was really 2, 3. So the Euro weeklies kind of they were bad too, but they at least got to phase 2 by July 4th, where the CFS wasn't getting there. So yeah, I think that was a problem as well for it. But yeah,
So
just tricky.
where was it? Okay, yeah, it was.
Well, yeah, this is from the 9th, it looks like, but I think our forecast for this period was from the 15th.
I see. So you're saying that not so much where it was observed, but the actual forecasts did not verify well.
Yeah, yeah.
Okay.
Yeah, for the
for the 16 to 20, which would have
well,
been.
it's all week this time of year. Yeah,
Was
from
that
the 15th of June is when it would have been
right?
visualization date.
Right. It's 13. God, it's all squiggly, but yeah. I mean, looking at this evolution, the actual evolution. I mean,
Oh, it was a mess.
yeah,
Yeah.
complicated, right?
Yes, it was. Yep.
Just looking at this, it appears that there's multiple, probably, tropical wave interactions, maybe Kelvin waves, maybe Rossby waves, but a complex sort of situation here, which, yeah, obviously can throw some havoc into the models and such. So yeah, that seems like a reasonable place to start in terms of if I was doing a deeper dive or case study into why such errors in the Arctic area, Canada and such, looking at some of the tropical forcing due to the, at least in part, with the MJO. Yeah. And last thing on my end before we'll let you guys go. Did I hear? I think I heard on the news that now Death Valley and some areas in the Southwest may approach some all-time record highs. Is that what you guys are seeing too in the next few days, or anybody?
Yeah, my our colleague William did an article about that. He focuses on the Western heat, and it looks like a really strong event setting up for this coming weekend into early next week. Really interesting. Not so much Burbank, actually. They're only in the low 90s, but when you get towards Sacramento, we're looking at 108 to 112, and in this, we call it the Palo Verde contract between Phoenix and Las Vegas. It trades quite heavily in the power markets, and we're getting up there. It's not as much as it was pre-monsoon season. They were getting up to like 118 in Phoenix and things like that, but we are 113, 114 in our forecast for Phoenix this weekend, and 116, 117 for Las Vegas this weekend. And I want to say Vegas's records are, let me pull it up real quick. Yeah, we're breaking records. So 2012 was the record before. They had hit 113 today. We're going 116, and for tomorrow in Vegas, we're going 117, and the record's 114 from 2012. Usually, once you get into July, the monsoon starts to diminish those records. They're not as impressive as they can be in June sometimes. And so, yeah, looks like we're going to knock them out. It looks like here in the next few days. Crazy.
So I lied. One last question. This is really not fair for a 2-minute, but so we've seen the ridge, at least it seems like the most extremes in the Western states so far this year. Obviously, we've had some decent heat in the East too, but like just off the charts in the West. Long story short, for sort of the back end of July into August, is it more likely you think that that extreme kind of weather stays more west, or are there any sort of leading data points here that suggests that ridging could shift more into the eastern half of the country?
Joe, do you see anything that's going to shift anything at this point?
No, I don't. I think, I mean, at least through August here, I mean, that drought magnet almost for the ridge there in the west. I mean, some of the analogs that I was finding, and for September, are cooler in the west. But again, that's not though. I'm not taking into account the drought in those cases. So I think that's really one of the big drivers at this point is it's just keeping it so stagnant there.
Wow.
It's off the scale drought too. I mean, it's
Wow.
just so much stronger than anything we've seen in
Yeah.
recent decades. So it's just hard to work with. You don't have a good analog set. But we have this thing on our website called the teleconnection mashup, and it keeps wanting to put the ridge in the northern plains and upper Midwest, and yet the answer keeps going back to the western states. So like Joe said, the drought magnet, and that's kind of seems like it just you take what the models are telling you and you just shift it to the west. So you look at the verifications over the last several weeks,
Yeah.
you just have to take that axis and pull it to the west coast, Seattle, Portland, as we saw, and then at times in California. But it's definitely a bias there for the models not to be far enough west with the heat intensity.
Okay, great. That's awesome. I think we can leave it there. Thank you so much for participating today, giving us the tropical update and some tidbits here about the forecast for the rest of the summer. This has been really helpful.
Good talking to you. Thanks for having us.
Right.
Yeah, thanks.
See
Thanks
you
a
guys
lot.
soon.
Take
Have
it
a good
easy.
weekend.
Thanks. You have a good one too.
All right. Thanks,
Take
guys.
care, everyone.
Thanks, guys.
Bye-bye.